Welcome to Metrology lecture series. In the present lecture, we will discuss the various types of fits. First, we will see the definition of the fit. Fit is the degree of tightness or looseness between two mating parts to perform a definite function when they are assembled together. Fit is the relationship between the two mating parts with respect to the amount of tightness which is present when they are assembled together. So next we have to see the types of the fits. So there are three basic types of fits can be identified depending on the actual limits of the hole and the shaft. First one is the clearance fit. Second one is the transition fit. Third one is the interference fit. So these fits are subclassified as the clearance fit, subclassified as slide fit, easy slide fit, running fit, slack running fit, loose running fit. Similarly, transition fit subclassified into the push fit and ringing fit. Similarly, interference fit is the subclassified into force fit, tight fit and the shrink fit. First we will see the clearance fit. Clearance fit is exists between two mating parts when the largest permissible diameter of the shaft is smaller than the diameter of the smallest hole, which means clearance fit exists when upper limit of the shaft is less than the lower limit of the hole. So let's see the in the picture. So clearance means it is the gap. So when the gap will be exist between the two mating parts mean, so upper limit of the shaft. So this is the upper limit of the shaft should be less than the lower limit of the hole. So this is the lower limit of the hole. So in this condition only, so clearance will be exist. So the condition of the clearance fit is upper limit of the shaft should be less than the lower limit of the hole. And clearance fit is a always provides the clearance. And the amount of the clearance is depend on the limits of the hole and the shaft. So maximum clearance will be exist, that is the difference between the upper limit of the hole minus lower limit of the shaft. So let's see in the picture. So here maximum clearance it will be exist. So this is the maximum clearance. Here what is the amount of maximum clearance mean? So difference between the upper limit of the hole and lower limit of the shaft. So upper limit of the hole minus lower limit of the shaft is the maximum clearance. Similarly, what is the amount of minimum clearance mean? So it is the difference between the lower limit of the hole. So this is the lower limit of the hole and upper limit of the shaft. So this is the upper limit of the shaft. So the difference between these two we are calling as the minimum clearance. So when the small clearances are provided for a precise fit that can easily be assembled with the assistance of the tools. Similarly, when the relative motions are required, large clearances can be provided. So let's take the example, a shaft is rotating in a bush. So in the case of the clearance fit, the difference between the sizes is always positive. So there are the different kinds of the clearance fit. So first one is the slide fit. So slide fit has a very small clearance and the minimum clearance almost zero. So it is the minimum clearance being zero. Sliding fits are employed when the mating parts are required to move slowly in relation to the each other. So examples of the slide fit First one is the tile stalk spindle of the lathe, sliding change gears in quick change gearbox of a center lathe, etc. So these are the example for the slide fit. Similarly, second kind of the clearance fit is the easy slide fit. So this type of fit provides for a small guarantee clearance. Here, so very small clearance it will be provided. It serves to ensure alignment between the shaft and hole, and it is applicable for the slow and non-regular motion. For example, spindle lathe machine and the dividing heads, piston and sliding valves, spy guards, etc. are the example for the easy slide fit. So next type of the clearance fit is the running fit. Running fit is obtained when there is an appreciable clearance between the mating parts. The clearance provides a sufficient space for lubrication film between the two mating friction surfaces. And in general, running fit is employed for rotation at moderate speed. For example, gearbox bearings, shaft pulleys, crankshaft in their main bearings. These are all the examples for the running fit. Similarly, have to see the other kind of the clearance fit, that is the slack running fit. It is obtained when there is a considerable clearance between the mating parts, and slack running fit may be required as compensation for mounting errors. For example, arm shaft of the LC engine and shaft of centrifugal pump. So these are the examples. So last one have to see the in the clearance fit, that is the loose running fit. Loose running fit is employed for rotation at very high speed. So let's take the example, ideal pulley on their shaft such as that used in quick return mechanism of a planer. Next we will discuss the interference fit. Interference fit exists between two mating parts when the minimum permissible diameter of the shaft exceeds the maximum allowable diameter of the hole. And interference fit always provides interference, and this interference fit is the form of a tight fit. So in the schematic you have to observe that one. So this is the interference fit. So condition of the interference fit is the lower limit of the shaft. So this is the lower limit of the shaft should be greater than the upper limit of the hole. So this is the upper limit of the hole. So it should be lower limit of the hole should be greater than the upper limit of the hole. So this is the condition for the interference fit. And amount of the interference, it is the depend on the lower limit and upper limit of the hole and the shaft. So what is the amount of the maximum interference mean? So this is the maximum interference. So what is the amount of maximum interference? So it is the difference between the lower limit of the hole. So this is the lower limit of the hole and upper limit of the shaft. So this is the upper limit of the shaft. So maximum interference equal to the lower limit of the hole minus upper limit of the shaft. Similarly, what is the amount of minimum interference mean? It is the difference between the upper limit of hole minus lower limit of the shaft. So this is the minimum interference. This is minimum interference. What is the amount of this minimum interference? It is the difference between the upper limit of the hole. So this is the upper limit of the hole minus lower limit of the shaft. So this is the lower limit of the shaft. So this is the amount of maximum interference and the minimum interference. So in the interference fit, there are required for the precise assembly of two parts with an interference fit. So it is actually a tight fit. In this required, we have required the special tools to assemble of the two parts when there is an interference fit exist. When two mating parts are assembled with an interference fit, it will be almost permanent assembly. That is, the parts will not come apart or move during the use. And moreover, to assemble the part with interference, heating or cooling may be required, because here shaft dimension is the larger than the hole dimensions, then it will be enter into the hole. So in this condition, we should have to the heating and cooling process is the required. And in the interference fit, the difference between the sizes is always negative. So in the clearance fit, the difference between the sizes is always positive, but in the interference fit, the difference between the sizes is always negative. So let's see the examples of the interference fit. Steel ties on railway car wheels, gears on intermediate shaft of trucks, bearings in the gear of a lathe headstock, drill bush in jig plate, cylinder liner in a block, steel rings on a wooden bullock cart wheels. These are all the examples for the interference fit. Next, we will discuss the different types of interference fit. First one is the force fit. Force fits are employed when the mating parts are not required to be disassembled during their total service life. So it is the permanent joint. Then only have to go for the force fit. So in this case, interference is quite appreciable, and therefore assembly is obtained only when high pressure is applied. So let's see examples for the force fit. So gears on the shaft of a concrete mixture and forging machine, etc. So these are all the examples of the force fit. And moreover, this force fit offers permanent type of the assembly. So next we have to see the tight fit. So tight fit provides less interference than the force fit. Tight fits are employed for mating parts that may replace while overhauling of the machine. For examples, stepped pulleys on the drive shaft of a conveyor, cylindrical grinding machine, etc. are the examples of the tight fit. So next we have to see the shrink fit. So it refers to maximum negative allowance. Hence, considerable force is necessary for the assembly. The fitting of the frame on the rim can also be obtained first by heating the frame and then rapidly cooling in its position. So shrinking it will be happens. So that's why we are calling it as the shrink fit. Next we will discuss the transition fit. Transition fit lies midway between the clearance and interference fit. So in the transition fit, diameter of the upper limit of the hole is greater than the diameter of the lower limit of the shaft, and moreover the diameter of the lower limit of the hole is smaller than the diameter of the upper limit of the shaft. So this is the schematic representation of the transition fit, and this is the upper limit of the hole, and this is the lower limit of the shaft. So let observe the condition. So for a transition fit, first condition is upper limit of the hole should be greater than the lower limit of the shaft, and one more condition also there. So this is the lower limit of the hole and this is the upper limit of the shaft, and one more condition here, lower limit of the hole should be less than the upper limit of the shaft. So remember, for this condition, to form a transition fit, the mating part should be satisfy these two conditions. Upper limit of the hole should be greater than the lower limit of the shaft, and the lower limit of the hole should be less than the upper limit of the shaft. So in the other words, the combination of maximum diameter of the shaft and minimum diameter of the hole result in a interference fit, while that the minimum diameter of the shaft and the maximum diameter of the hole yields a clearance fit. See, transition fit is the lies midway between the clearance and interference fit. So it depend upon its dimensions, the fit also it will be vary. And moreover, since the tolerance zone is overlap, this type of fit may sometimes provide clearance and sometimes provide the interference. See, this is the tolerance zone for the hole, and similarly this is the tolerance zone for the shaft. So here, so tolerance zone for the hole and the shaft, it is the overlap. So in this position, so tolerance of the hole as well as the tolerance of the shaft is overlapped. So sometimes depend upon the its dimensions of the hole and the shaft, sometimes it may be this type of fit may be provide clearance, or maybe sometimes it will be provide the interference fit. So next we have to discuss about the different types of the fits in the transition fit, that is the push fit and the ringing fit. So first I have to discuss about the ringing fit. A ringing fit provides either zero interference or a clearance. So these are used where parts can be replaced without difficulty during the minor repairs. Similarly, second kind of the push fit is it provides the small clearance. It is employed for parts that must be disassembled during the operation of a machine. Let's consider the examples: changing gears, slip bushing. These are all the examples. So these are the various kinds of the fits, and thank you.